This video is about operations with radicals. And in order to add or subtract radicals, the terms must be like terms. So we've seen that many times before in combining simple like terms like 3a, 10a, and negative 2a. So 3a plus 10a is 13a minus 2a is 11a. So the variable expression is the same. The power is all exactly the same. In order to add or subtract, we must have like terms. 14x squared or xy squared z plus 10xyz squared. So we've got different variable expressions, therefore number 2 is completely simplified. Number 3. In number 3, we have 10 radicals of 3 plus 14 radicals of 3. How many rad 3 do we have altogether? The radical is not going to change. We're just going to combine the coefficients. 10 roots of 3 plus 14 roots of 3 is 24 square root 3. The radical has to be exactly the same, both the index as well as the radicand, which in number 4, this is 7 square root 5 minus 6 cube root 5. This is fully simplified because these two radicals have a different index. Lastly, number 5, negative 3 square root 8 plus 10 square root 50. Well, as it appears, they do not have a like radicand. However, I hope that everybody can look at 8 and go, well, I know what 8 is. The square root of 8 is 2 root 2, because that should be one you're very familiar with. So 3 square roots of 8 can be simplified to negative 6 square roots of 2. We can also simplify the square root of 50. So if we quickly look at the prime power factorization for 50, 5 times 10, 2 times 5. So 50 is 5 squared times 2. So if we have a 10 out front, that 10 is staying, and then 2 goes into the 2 one time. So 1 power of 5 is coming out, and a power of 2 remains under. So when we multiply here, we're going to end up with negative 6 root 2 plus 50 square roots of 2. And when we combine like terms here, negative 6 root 2 plus 50 root 2 is positive 44 root 2. So sometimes we are going to need to simplify the radicals first before we can add or subtract. If we're multiplying, all we got to do is use the commutative property and the associative properties to rearrange the parts of the radicals to help ourselves. So let's take a look at this problem. And the first thing I'm going to do is I'm going to group together all the coefficients. So using the commutative property, I can change the order, and the associative property allows me to change the groupings. So negative 2 times 3 times 4. And then I'm going to put together all under one radical, the 5, the 10, and the 14. Now, 5 times 10 times 14 is 140 times 5, which is 700. That's fantastic. But what would be even easier, rather than multiplying that out, is to think about the 5, the 10, and the 14 in terms of the prime power factorization, because this will more quickly take us to the simplified radical. So 5 cannot be broken, but 10 is 5 times 2, and 14 is 2 times 7. So there's 5, there's 10, there's 14. In terms of a prime power factorization, we have the square root of 5 squared times 2 squared times 7 to the first. So think about what's coming out 1 power of 5 is coming out, 1 power of 2 is coming out, and the 7 is going to stay under. So this is what's technically getting multiplied to -2 times 3 times 4. So now might be the best time to start multiplying. So first of all, 2 times 5 is the 10, and this is -6 times 4, that's -24. So when we multiply straight across, 24 times 10, so -240 square root 7. Use the commutative property to change order when necessary, and the associative property, which will allow us to change the groupings. If we have a binomial times a binomial, remember the prefix bi means 2, so a polynomial with 2 terms, so a plus b times a plus b. If we have this situation, we've got to do a double distribution. A double distribution, so 3 times 4 is 12. 3 times root 5 is 3 root 5. Then the second term, negative root 5 times 4, negative 4 root 5, and then negative root 5 times positive root 5. Remember, a square root times itself is an inverse operation. We end up with -5. So our like terms are on the front end and the back end, and then in the middle. So 12 minus 5 is 7. 3 roots of 5 minus 4 roots of 5 is -1 root 5. Let's do it again. And remember that these two binomials have a special name. We looked at them in the previous video. One's a sum, one's a difference. They are called conjugates. And when we multiply conjugates together, the middle terms will cancel. So let's do the double distribution here. So 10 times 10 is 100. 10 times -3 root 7, -30 root 7. And then positive 3 root 7 times 10 plus 30 root 7. Those are those middle terms that are canceling. Positive 3 root 7 times -3 root 7. Remember, this is the tricky one, and this is where people make a careless mistake. So pay attention to what's happening. Think about the coefficients first. 3 times 3 is 9. 3 times -3 is -9. Then root 7 times root 7 is 7. So we're multiplying these two together. If you want to see that on the calculator, this is how you would enter it in on the calculator. You would say parentheses 3 square root 7, close those parentheses, and then square it. That's what's going to give you 63. If you don't use the parentheses, watch what happens. 3 square root 7, and then squared, you only end up with 21. Without the parentheses, you're only squaring the radical, not the coefficient. You cannot overuse parentheses, so pay attention to that little fact. So what do we have left? Middle terms canceled as expected because these are conjugates. We're left with 100 minus 63, and 100 minus 63 is 37. So the product of those two conjugates is the whole number 37. Quickly, 2 more problems and then this video concludes. This is a binomial being squared, so it would be prudent to write it out twice. I'll do this one quickly. So first sides, remember 7 root 2 times 7 root 2, 7 times 7, 49. Root 2 times root 2 is 2. 7 root 2 times -8, -56 root 2. Another -56 root 2, and then plus 64. This time, middle terms don't cancel. The middle terms double when we square a binomial. So 49 times 2 is 98, plus the 64, minus 56 root 2, minus 56 root 2, which is -112 root 2. Remember that the radical does not change when adding or subtracting. So 98 plus 64 would be 162 minus 112 root 2. One last one, do the double distribution. So 3 root 3 times 2 root 10 is 6 square root 30. 3 root 3 times 7 root 14 is 21. Square root 3 times 14 is 42. In the middle, minus 8 square root 60. And then finally, minus 28 square root 6 times 14 is 84. Now, we need to simplify these radicals. 30, think about its prime power factorization. Its prime power factorization, that would be 6 times 5, so that would be 2 times 3 times 5. Nothing's coming out. 21 square root 42. 42 is 6 times 7, so 2 times 3 times 7. Nothing's coming out. 60. 60 is 6 times 10, so that's 2 times 3 times 2 times 5. There is a pair of 2's, which means there is a 2 coming out, and 3 times 5 will be left under. Obviously, 84 is divisible by 4. It's 4 times 21, so that's 2 times 2 times 3 times 7. So underneath that radical is a pair of 2's, so that means a 2 is coming out, and a 21 or 3 times 7 will be left over. Now, if we just kind of clean up this mess here, so the first two terms are staying the same, so that's 6 root 30 plus 21 root 42 minus 16 square root 15 minus 56 square root 21. A very messy last problem, but that's what we get when we multiply those two binomials together.